Okay, so yesterday we talked about adding integers. Today, our topic is subtracting integers. Okay, we use a strategy with subtracting integers to kind of change up our subtraction problem, because when we're subtracting integers, we kind of run into a problem here, okay? So let's say we have, and you don't have to write this part. Let's say we have 4 negatives, okay? And I want to subtract, I'm gonna pull out another sheet of paper. We have -4 minus 3 positives, right? Hopefully you can see that. -4 minus 3. Here's the problem, okay? -4 minus 3, that means I have -4 things, and I need to take away 3 positives. Well, do we have 3 positives to take away? There's no yellows over here, right? So there's no positives to take away. So here's the thing mathematically. What's the only thing that you can add to an equation or to an expression that doesn't change its value? What's the only thing that you can add? Hopefully you said 0, right? So I can add a 0 to this and not change its value. How do I add a 0? Do you guys remember from yesterday, your notes from yesterday, something that basically means 0 in the integer world? I'm going to show you, hopefully you remember this from yesterday. A 0 pair is a whole number and its opposite whose sum is 0. Do you think I could add a 0 pair to this to get me what I need? Because how many positives do I really need to be able to take away? I need to be able to take away 3 positives. So could I add, there's a 0 pair. Do I have enough yet to take away 3 positives? No. Could I add another 0 pair? This still equals -4, but I just have some 0 pairs there, right? Could I add another 0 pair? Now, this is still -4 because these are all 0, but now do I have enough to take away the 3 positives? Absolutely. So -4, again, I'm going to take away my 3 positives, and this would equal what's left, -7. Okay, so we're going to use a strategy that basically does what we just did, and it's called LCO. We're going to leave the first term the same, which is right here. We're going to change subtraction to addition, which that's why we put these 0 pairs in here. And we're going to take the opposite of 3, which is -3, and that's what gave us our -7, okay? You don't have to really understand that part. The whole point of this right here was just to show you why we use LCO, because with subtraction, we have to kind of manipulate that subtraction problem into an addition problem. So let's talk about LCO for just a second, okay? LCO stands for what you already heard, leave, change, opposite. So the L stands for leave. We're going to leave the first term alone. Leave the first term alone. Leave the first term. That means don't do anything with it. You're just going to leave it alone. C stands for change. Just like we did, we changed subtraction to addition. Change subtraction to addition. And then O stands for opposite. We're going to take the opposite of the second term. Notice I'm not putting number because eventually there's going to be a variable on that term. So I'm not just putting number, right? I'm going to put term. And I'm just going to put that every time that we are subtracting integers, we're going to use LCO. Here's what some of your other teachers, maybe in prior years, they've called it KCC, right? Keep, change, change. They may have called it keep, change, flip. Okay? So it is literally the exact same thing as leave, change, opposite. The reason we use leave, change, opposite is because opposite is more of a mathematical vocabulary, and we want to make sure that we understand what we're doing with that piece. So what I'm going to do, I'm going to take my paper and I'm going to draw a big box around the whole rest of my paper, and I'm going to split it into 6. Okay? So that means I'm going to draw a line down the middle of my box. And then I'm going to draw 2 more across. Line down the middle, 2 more across, just like that. So our first example, and I want you to write it and then I want you to rewrite it with me every single time, okay? First example looks a little bit like this. Negative 94 minus negative 73. 94 minus negative 93. And I think this one does start out as negative. I'm sorry, guys. Negative 94 minus negative 73. So let's rewrite that. And I'm going to use, if I can get this pen to work. Nope, different color. Okay. I'm going to use this pink one to rewrite negative 94 minus negative 73. And we're going to do our LCO step, okay? Remember, LCO stands for leave the first term alone, change subtraction to addition, and I want the opposite of negative 73, which is positive 73, okay? So after LCO, we left the first term alone, we changed subtraction to addition. I need the opposite of negative 73, which is positive 73, so this becomes negative 94 plus 73. Now it's just an integer addition problem, right? So now it's just an addition problem. Are these two on the same team? No, they're not. If they're not on the same team, then they have to battle, which means I do an itty bitty bit of subtraction. 94 minus 73. So there's 21 left over. And which team wins the battle? Which team has more soldiers? Which team has the larger absolute value? The negative. Okay? Notice, all of this part is from yesterday's lesson. All of that is just adding integers. What we did is we took the subtraction problem, we manipulated it back into an addition problem. Remember, we did that with our chips from the beginning when we added in those 0 pairs. That is why that mathematically works, okay? All right, let's look at the next example. So this next problem is gonna be 35 minus 68. 35 minus 68. You might be thinking, well, this looks kind of normal. Well, if I have $35, can you take away 68 of them? I mean, you can, right? But I would have a red bank account, wouldn't I? Yeah, that's too much money to take out of there. So I'm gonna rewrite it down here, 35 minus 68, and I'm gonna do my LCO step in another color, okay? I always wanna have the original up here just so I can see how it started. I'm going to leave the first term. C stands for change subtraction to addition. And I need the opposite of 68, which is negative 68. Leave the first term alone, change subtraction to addition. I need the opposite of 68, which is negative 68. So now we got 35 plus negative 68, which is just an integer addition problem. Okay, just an addition problem. So again, if I cover everything else up here, are these two on the same team? No, they're not, so I have to do a tiny, tiny, tiny bit of subtraction. Is this a subtraction problem anymore? It's not, but remember I gotta take out the 0 pairs, which is why I'm doing a teeny tiny bit of subtraction. 8 minus 5 is 3, 6 minus 3 is 3. in your head, go ahead and think about, is your answer going to be positive or negative? Which team wins the battle? This negative team has a larger absolute value. It has more soldiers, so negative wins the battle. Okay? All right, let's go ahead and do our next two examples. Zoom in here just a little bit if I can. Okay? This one, 63 minus negative 38. 63 minus negative 38. So let's go ahead, 63 minus negative 38, and let's do our LCO step. Leave the first term alone. Don't do anything with it. C stands for change, subtraction to addition. I need the opposite of negative 38, which is positive 38. Here's what a lot of people do. They'll do the L and the C, but they'll forget to actually do the O, right? You actually have to change this number to its opposite, okay? So now we have 63 plus, and this is positive 38. Well, that's an easy one, right? Are these on the same team? Yes, they are. So I'm gonna group them, right? Same team, you group 8, 9, 10, 11, 6, 7, 8, 9, 10, 101. They were both positive groups, so they just grouped together as an even bigger positive group. Alrighty, next question over here. This one, you're gonna think you know the answer, be so careful. Negative 34 minus negative 34. Negative 34 minus negative 34. All right, let's rewrite it and do our LCO. Negative 34 minus negative 34. First step is to leave the first term, change subtraction to addition. I need the opposite of negative 34, which is positive 34. So what this becomes is negative 34 plus 34. Are these on the same team? Do they have the same sign? No, they do not. If they don't, we're supposed to battle, right? Battle just means to do a teeny tiny bit of subtraction. You might already see in your head that 34 minus 34 is gonna be a 0. Isn't this a 0 pair? Positive 34 and negative 34, isn't that a 0 pair? Absolutely. Which team wins? Well, they kind of all cancel each other out, so we have 0 left over. And just a hint, we do not have a negative 0, okay? So negative 0 is not a thing. 0 is neutral, so it's just 0. There's nothing left. If there's nothing, then it can't be positive or negative, right? Okay, last two examples. This next one, I'm gonna show you an example of how it works with just a regular old number that you probably could have done regularly. However, I do want to show you that it still works, okay? So this looks like positive 81 minus 78. I feel like some of you guys can already see the answer in your head to this one, right? That's okay. Let's go ahead and just prove that it works. We're going to leave the first term. We're going to change subtraction to addition. And I want the opposite of 78, which is negative 78. Are these on the same team? Let me rewrite this, 81 plus negative 78. Are these on the same team? They're not. If it's an addition problem, they're not on the same team. I battle, which means I do just a tiny bit of subtraction. Some of you have probably already counted up, right? 78, 79, 80, 81. So there's 3 left over. Which team wins? Which team has more soldiers? Which team has the larger absolute value? There's 80, positive 81 has the larger absolute value, so my answer is positive. Okay, very last one. 58 minus 132. Let's rewrite it and do our LCO. 58 minus 132. Again, if I have 58 things, I can't take away 132 without doing some manipulation of this expression. So we're gonna use LCO. We're gonna leave the first term. We're gonna change subtraction to addition. And we need the opposite of 132, which is negative 132. So this becomes 58 plus negative 132. The greatest thing, if you know how to add integers, every subtraction problem turns into an addition problem. The reason that we use LCO is to avoid computational errors. 7th graders do not get a calculator on their STAR test. So to avoid computational errors, we use LCO with equations, we use LCO with expressions, with rational number operations, because it helps us to avoid errors, okay? All right, these two, they do not have the same sign, they're not on the same team, so we would battle, which just means it is an addition problem, but to take out those 0 pairs, I need a tiny bit of subtraction. Is this now a subtraction problem? It is not, but I'm taking out my 0 pairs by using a little bit of subtraction. 132 minus 58, you've probably already gotten that, is 74. Okay, and then which team wins the battle? Which team has the larger absolute value? Which team is farther from 0? The negative team, so our answer is negative. Okay, so just to review really quickly, LCO, leave the first term alone, change subtraction to addition, and then take the opposite of the second term, okay? Good luck. Remember, every subtraction problem just turns into an addition problem, so that will be helpful as you move along.